welcome everybody. Thank you for taking time out of your very early summer holidays to come out to this. I really do hope that we meet some of your needs. I am going to share my screen, and I will stop sharing my video because I have bandwidth problems. So I will say goodbye to you now that you know what I look like, and I will start sharing my screen. And it was right here before. There we go. Nope.
Yeah, that's it. We're good to go.
We're good to go.
Yep.
Excellent.
Good news.
Excellent news. All right, so I really have learned a lot about mathematics, even though I studied mathematics. I didn't study mathematics because I was good at it. I studied it because I really liked it. But being a teacher, I've learned the why of so much of what I learned the how of. And the why is so much more interesting than the how. And so we're going to go on a little journey today here. And I hope this speaks to some of you. I don't know who you are. One of the things I learned doing adult education courses is you should always meet the needs of the people in your space, but I don't know you well enough to ensure that I can do that. So please, if I'm not, send a message to Ian. I'm not really seeing the chat because I'm sharing my screen. So send a note to Ian and he'll stop, and we'll see what we need to do in order to be better at meeting your needs. Again, as much as we can, we'll meet the needs of the group, not necessarily the individual. However, I have shared my email, and I have absolutely no problem unless there's something forbidden here. If you have a question specifically as you're going through the summer and you're practicing and you just don't understand why something is happening, I'll do my best to help you. So that will
That's
come
really
up.
generous, Judy.
Oh, it's my pleasure. So here we go. I have, I'm going to share, they're going to be very bold, some of the key things that I've learned that I like to share with my students that I believe made a real difference for them. And are you seeing that? Because on my screen, it's sort of not positioned properly.
Yeah, we can see it, but it's cut. It says math is not at the top, just cut off a little bit.
Okay. I don't know why, because it was fine before, but here we go. So yes, it does say math is not compatible with stress. There have been many, many studies that actually show that when people are stressed, their math scores go down. Unlike, say, the Olympics, where if you've got your adrenaline pumping, you do better, you perform better. This isn't true with math. So it's really, really important for you to try to get yourself in a relaxed state before you start writing the proficiency test. Simple thing to do is some deep breathing exercises. The deep breathing exercise that was introduced to me that worked really nicely was box breathing. You breathe in for 4, hold for 4, breathe out for 4, and hold for 4. And if you do this a few times, 4 or 5 times, you should start to feel a physical change. Your shoulders will go down, your neck will feel longer. Your pulse will actually start to drop, and you will be in a better place in your mind for you to start doing math questions. As well, if you come across a question, you start the test, the first question is one that you're not familiar with, you don't know how to do it, all of a sudden your stress goes shooting up again. So it's a test where you can skip questions and go back to them. And you will find that as you focus on a question that you know how to do, your stress level will go down. So these are just really simple tools that actually work when you're doing math tests.
Judy, that one's front and center on our screen. That's perfect.
Fantastic. So one just blooped up, I guess. Thanks. You may have spent 12 years in elementary and secondary school being taught to believe that there's only one right way to do a math question. And in fact, you may have been marked that way. You may have been marked with little ticks on each of the lines that you successfully completed, with an X at the line that where you veered off course. We know that that's not true. People who do mathematics know that's not true. And in fact, that is expressly not what the curriculum says. And it's particularly not what the new curriculum says. The new curriculum values any student's way of seeing mathematics, any way that they choose to do a problem. So I want you to recognize that it doesn't matter how you do the problem. It is important that you do the problem. So if you have a different way of seeing a problem than maybe you recall having been told you needed to do, forget about it. Just do it the way that's comfortable to you. You understand yourself and your way of thinking. It's fine. Mathematics is about thinking and relationships. That's what it actually is if you were looking for a definition about mathematics. It's about identifying and analyzing patterns and relationships between things. So if you find yourself in a position where you don't remember how to do something, that's what's in your head. It's, I don't remember how to do this. That's probably because you learn mathematics as a set of memorization steps, and you didn't really, you had nothing to fall back on if your memory fails you. So we're going to try to build some of that today. I have to say that mathematicians are in more demand than ever, and yet computers do all their computations. So it's not about computing. It's about thinking and seeing patterns in things. They're all over trying to analyze COVID, and that's not about computation. The computers are doing the computation. So as you practice, try to ask yourself the question, why is this working? I was saying to Ian the other day, there really aren't that many different things in mathematics because they're all connected. So if you can start to build those connections for yourself, you'll build such a much stronger foundation than if you just try to memorize a bunch of discrete facts, formulas, and procedures. Time. We also know that mathematicians quite frequently talk about how they were told they weren't any good at math when they were in school because they weren't very quick. Well, mathematicians are reflective thinkers. And so if you were convinced that you're not good at math because you couldn't do it fast enough, please take that message away and replace it with, you know what, I'm just as good at math as anyone else. I just may reflect more as I'm doing it. We've managed to convince people that they're not good at math, that they're born that way. And in fact, there's no such thing. Everyone can be good at math, but they can very easily be convinced that they're not good, especially when they see lots of red X's. I promise you that you know everything you need to know in order to pass this test. Because it isn't a grade 9 content test. That's not what it's about. It's a proficiency test. Chances are, if you saw these questions and they weren't given to you in a high stakes environment, you'd be able to answer them, or most of them. So you're not trying to prove here that you're capable of passing a grade 9 content test. What you're doing is you're demonstrating your competence to help students deal with the math that they will see in their non-math courses, like geography, history, physical education, science and technology. So you've got this. I know you've got this. You do math every day. It's just not the same math as you saw on worksheets when you were in school. So just to demonstrate, this is, and I was happy to see people from PJ, this is just an expectation from grade 1 social studies curriculum that students will be able to talk about scale. And scale is just ratio and proportion in math class. So, you know, if you think of a map, 1 centimeter represents 100 kilometers. How many kilometers does 3 centimeters represent? Well, now that sounds like a math question, but you do it routinely because you know what you're doing. It's just when you pull it out of context and you stick it as a word problem, all of a sudden it causes your stress levels to go up, and you can convince yourself that you don't know how to do it when in fact you do. So shopping and cooking are about ratio and proportion, which is a large component of the math proficiency test. You know, you go to the store, you're buying something that's $12.95, but you want 3 of them. So you're setting up in your mind a proportion. 1 item costs $12.95, then 3 items will cost how many dollars? That's a proportion. You're getting 50% off $35. How much do you need to pay? Well, 50% is 50 to 100. That's the ratio of 50 to 100. And the full price, the 100% was the $35. So how much are you going to have to pay? You have a recipe that serves 4. You only want to make for 2. It calls for 6 ounces to make 4 portions, but you only want to make 2 portions. How many ounces do you need? So again, you do this all the time, but you do it in a meaningful way that has context and you know what to do. So I hope I'm somewhat convincing you that you really do know how to do these questions. I know you do them all the time. The math processes have actually been part of the math curriculum since 2005, although I suspect that many students who went through school from 2005 to recent years don't remember ever hearing about them. They're the only thing that continues from grade 1 through grade 12 as an expectation, because they are the heart of mathematics. And so reasoning is really important. Reflecting is really important. Making connections to things you already know, either from other courses, from other math classes, or from your life, your day-to-day life. All of this strengthens your ability to understand the mathematics that you're doing. Representing, again, you may have had a teacher who said it has to be done this way. You didn't understand it done that way. You don't have to do it that way. You can represent it differently and make it more meaningful to you. So I want you to remember that this is actually a strand now in the new grade 9 curriculum, an overall expectation. So it's taken a new level of prominence. It's half of a strand in the elementary. It's part of strand A. It's strand A is social emotional learning in mathematics and the mathematical processes. So get to know them. They are your friend. They will help you formalize your mathematical thinking. All right, so just to make a point about representing, maybe you read a question like this. This is from the practice test for the math proficiency test. A rectangle is cut into fourths. Each fourth is cut into 4. And maybe the words aren't meaningful to you. So you draw a rectangle and cut it into fourths. So now you've got that first part, a rectangle cut into fourths. This is representing the words in a visual way. This is visualizing your thinking, making your thinking visible. Each fourth is cut into 4 equal parts. You can do that any way you want. You can do it vertically, horizontally. You can cut it at each quarter into 2 diagonals. It doesn't matter how you do it. So now if you take one part is one of how many? So I'm going to ask you to answer that question.
And just to support everyone's learning, if you just put that in the chat, and when Judy asks for that, then we can sort of all put our answers in. That just helps support the learning there. So go ahead when you're ready.
Oops, sorry.
come the answers. So Judy, we've got 1/16, 1/16. I believe it's D, 1/16, D, 1/16. It's a trend.
Wonderful. We see a pattern.
Yeah.
So again, maybe the words were problematic. You draw a picture. They don't care. The math proficiency test folks don't care how you do it. And now it's just counting. So you changed maybe a question that was confusing to a question that really isn't confusing at all, I hope. This one was also from the practice test. Now it's set up to test your understanding, not to test your knowledge. And so 2/5. So what could you do? Well, you could take a rectangle and divide it up into fifths and look to see what 2/5 look like. But that doesn't look like any of the pictures that are given as multiple choice. So you have to now divide it into thirds, into 3 pieces horizontally. So you do that. But you know what 2/5 look like. All right, so the question is, how many squares represent 2/5? And which of those representations in the multiple choice answers would be the right answer? And again, you can answer in the chat if you choose to.
Go ahead and, yep. So we'll see lots of D.
So A has 2 shaded,
2 of every 5.
B has 4 shaded, C has 5 shaded, D has 6 shaded. You want 6 shaded. So yeah, the answer is D. Great. So that's what representing is all about. It's changing the information you're given and turning it into a different representation of that same information so that you can understand the problem. Now that's the way I would see it, but maybe you would represent it differently. Are we good to go to continue?
Sure. I've just had a question which I'll just answer here. This is recorded, so that, and it will be archived on our OTF YouTube channel. So you'll get a link to that 24 hours after this session. So rest assured, you'll see it there. Yeah, great. You're welcome.
Great. Okay.
Go ahead, Judy. So sorry.
Okay. So one more with respect to changing the representation so that you can understand the question. I know this question is problematic for many reasons, one of which is because it deals with fractions, one of which because it deals with patterning and identifying the pattern, and last because it asks for the 7th term, and that requires that you count correctly. So one of the things I would ask that you start to look at, and we'll do this a lot today, is to look at the answers that are given to you. You've basically got answers that are greater than 1 and answers that are less than 1. So a question that you can instantly ask yourself and would help you eliminate 2 of the answers, giving you now 2 to choose from instead of 4, is are those numbers getting bigger or smaller? Now, if you have 1 of 64 things or 1 of 8 things, if you have a rectangle cut into 8 pieces and you have 1 of them, or you have a rectangle cut into 64 pieces and you have 1 of them, yes, your 8th piece is going to be a bigger piece assuming it's the same rectangle, than your 64th piece. So those numbers are getting bigger. So this actually, it tells you that it's a growing pattern. It just doesn't look like it's a growing pattern.
Judy, that was the pattern of answers in the chat, that they were getting larger.
They're getting larger, thanks. Thanks. So how much larger are they getting? Well, I would suggest that you maybe set up a different way of looking at it. So I might set up something that actually tracks the terms. And I just put in the information that I've got. And I know I have to go to the 7th term, so I go to the 7th term in my little table. And now I'm looking for the relationship in the numbers that I see in that second row. 164, 1 over 32, 1/16, 1/8. And you can see a pattern there, I would say 2 different ways. I'm not sure which way you're going to see, but I see a pattern. Well, actually, maybe, would you like to share what you see in the pattern?
Sure, great idea. Folks can do that in the chat again.
Yeah.
Try to write or, I guess in writing, verbalize what you see. Okay, so I've got the denominators being divided by 2, divided by 2.
Good. And the numerator is staying 1. Good. Yeah. So that is, in fact, what you can notice is the denominator is halving each time. It's being divided by 2 each time. So you go, okay, 64, 32, 16, 8. So term 5 would be 1 over 4. Term 6 would be 1 over 2. And then term 7 would be 1 over 1. Now that dividing the denominator by 2 each time is exactly the same as multiplying the whole fraction by 2 each time. So if you multiply term 1 by 2, it grows to be 1 over 32. And then when you multiply 1 over 32 by 2, it grows to be 1 over 16. So dividing the denominator by 2 and multiplying the whole fraction by 2 are the same thing. And that's actually one of those rules that you learn to memorize that seems to come out of thin air, But you can see that that is actually what's happening. Whenever we multiply by 2, it's the same as dividing by half. Multiplying by half is the same as dividing by 2. That's what the numbers are telling us. No thin air. All right, so now you've got 3 out of 3, I think.
Yep.
We're going great.
Judy, could I ask you just as I'm looking at this, so there are 4 possible answers provided.
Yeah.
Could you give us a sense of why it's those 4 answers that are provided, and where folks potentially go wrong in this question?
I think
give the incorrect answer. Don't see the correct pattern.
Yeah. One of the places that is always difficult with patterning is knowing how to count. And so people will go 1 too few or 1 too many because they don't start counting at the right place. Like the 1 over 64 is the first term. How many more do you need to count? So, well, don't worry about how many more you need to count. Just count 7 and start with 1 over 64. I remember once helping one of the custodians at school came in and he said, "Oh, you teach math. Can you help me? I'm trying to do a fence and I can never get the right number of fence posts." And it was simply because he didn't know if he should start counting at 1 or at 0. Don't worry about it. Just draw it out and then you'll know exactly how many to do. And that's basically what I did with the table, is I drew it out. And it honestly takes way more time to put it onto a slide than it takes for you to just sketch it on a piece of paper. So again, nobody's watching you. You are free to do it any way you choose. It doesn't have to be a particular way. This, by the way, is a linear growing pattern because, no, it's not a linear growing. Scratch that. I'm thinking about another thing that I was going to do. We're going to go on to the next question before I make another mistake. All right. Okay, so the math proficiency test is multiple choice. You're not going to be marked on how you chose to do a question. In fact, another reason why it's absolutely not anything like having to do a grade 9 math test. Okay, it doesn't matter how you get the answer, just matters that you get the answer. It's also different from other multiple choice questions in that if you had multiple choice questions at university, which frequently we see because we've got 1,000 people, so they do a lot of multiple choice. Sometimes in a multiple choice question in university or in the professions, you'll get like a point for a correct answer. You'll lose a half a point for a wrong answer. You'll get a quarter of a point for a blank, up to a maximum of 10 or something like that, 10 answers or 10 questions. This is not like that. So what you want to make sure you do is answer every single question. If you have to guess, guess, but don't leave anything blank. It's definitely not to your advantage. If you have no idea whatsoever, you've got a 1 in 4 or 25% chance of getting it right. And again, nobody's going to say, okay, well, you did 3 of the 5 steps that I was looking for correctly. It doesn't matter how you do it. And you're free to skip questions. And as I said earlier, part of the stress is looking at a question and not knowing how to do it. And it's the first question. And so you skip it. Now you can't skip through the different sections. You're stuck within a section, but find a question that you know how to do. Skip the ones you can go back. You can always go back. But what you do want to do when you skip a question is you want to put it in your head. You don't want to skip it without reading it thoroughly so that you know what they're asking for. Because there's a really good chance that when you're doing 50 or so questions between the first 2 sections, there's a really good chance there's going to be another question that's going to remind you of something that maybe you weren't thinking of when you skip that first question. And when you go back to it, you'll know how to do it. But you have to remember that that's what it was about.
Judy, maybe you're going to cover this, so I'll leave that just to sit with you, or you can answer it now. It was a great question in the chat here. Is it true that the multiple choice answers for questions are common errors?
Yes, I mean, they're not random. They're all going to be mistakes that the people who write it know students are likely to make. For sure. Yeah.
Great, thanks.
So what we're going to do, we're going to explore a little bit of how we can avoid some of those things. All right. Again, one of the things that you want to do in a multiple choice question is see if there's anything that you can eliminate right away. Like, look for what's clearly not reasonable. If you can eliminate 1, your chances are better by 25%. If you can eliminate 2, they're better by 50%. If you can eliminate 3, you know what the right answer is. So what can you eliminate? Well, I'm going to lead this one. Okay. I look at those numbers, and it's a mess of decimals and whole numbers, and some of them have 1 decimal place, some of them have 2 decimal places. I could sit there and calculate. But again, I'm trying to use my thinking and my reasoning, and I don't have a calculator handy because this is part of the calculator is available part of the test. So I look at the numbers and I look at what can I see? Well, the whole number parts are 7, 5, 1, and 2. So I know because I'm adding them up that the answer is going to be at least 7 plus 5 plus 1 plus 2. And that's 12, 13, 14, 15. So it's going to be at least 15. Oh, I've got a 4. Sorry, I couldn't see the 4. I got to move the windows. Okay, there we go. Plus 4. 19. So it's at least 19. Okay, I've got 2 answers there that are less than 19. So they can't be right. So I can eliminate A and B. Now I'm down to C and D. And the difference between C and D is one is more than 20 and one is less than 20. So I look at the rest of the numbers and I go, well, is there enough there in those decimals to take me a whole number more? And then some. So I look at the decimals, and I see that just the two that have a single decimal place, I've got a 0.5 and a 0.5. That gives me a whole other one. So I know that I've gone over 20. So the right answer must be D. And if you want to, you can notice that the 0.05 and the 0.05 will give you another 0.1. You don't need to know that because you've reasoned your way to the correct answer. It can't be A or B or C or D. Sorry, or A or B or C, so it must be D. All right, so what can you do here to reason without having to do a computation, without having to set these up in a set of, lining up the columns with the decimal point? What can you see in those numbers?
You want folks to answer in the chat?
Sure.
Okay, go ahead then.
And then I'll share what I saw.
Yeah, great. And we're just experiencing a comfort with wait time here.
Wait time is one of the things that teachers struggle with the most. They've done studies. It's less than 3 seconds in your average classroom. And some students are still reading the question when the teacher is starting to give prompts for answers.
So in the chat box here, I can already see the answer will have a 1. Looking at the tenths column, the answer will be greater than 1. So C and D are out.
Nice.
But we have
nice. Thank you. That's what I looked at too. I looked at the tenths there, and I went, okay, well, that's more than 0.6 is more than a half. 0.7 is more than a half. So just adding those two together, I'm going to be more than 1, so I can get rid of C and D. That's great. And then one more thing I noticed was that there are 4 decimal places, and there's only one number that has 4 decimal places. And so there's nothing to add to that 5. So the answer is going to have 4 decimal places with a 5 at the far right in the 4th decimal place. So which one is more than 1 that has a 5 in the right place? It has to be B, yes? Okay. So yeah, if you look at those questions, the answers, you can see that the numbers are the same pretty much between A, B, and C. So what they're doing is they're checking to see, do you understand how to line up those decimals if you're doing it longhand as a tedious computation. Much more elegant, I think, much more fun to do it as reasoning. Like I can reason my way to this answer. I don't need a pencil and paper. And I don't need to rewrite those. If you rewrite them and you miss a dot or you miss a 0, you're toast. If you have to, that's great. Just be really careful that you count your zeros, especially when you've got a 0 in front and a 0 behind the decimal point, and then you've got 2 more to add as well. So yeah, it works. Obviously, the brute force computation will work and give you the answer. What I'm suggesting is if you reason, you actually don't need to, and you can do it faster without writing it all out and adding it up.
So Judy, also probably a great time for box breathing.
Probably a great time for box breathing. Yeah, you want to just keep doing it anytime you need to. So again, what am I describing? I'm describing looking for patterns. I'm looking for patterns in those numbers that can help me answer this question. All right. Same thing here. I'm not sure what time it is. 441.
It's 440.
Maybe I'll walk this one through, but while I'm walking through, you can also be thinking about what you might reason here. Without having to do the dreaded common denominator, I might reason that 11 over 5 is more than 2. So it can't be A or B. Now I've got to pick between C and D. And 1/7 is a little bit more than 0. So now I have to ask myself if the little bit more than 2 and the little bit more than 0 is enough to take me up past. Oh, no, we already know. I'm sorry, my mistake. We already know it's between 2 and 3 because 11 over 5 is bigger than 2, right? And again, no common denominator required. And that should make everybody relax. So I'm assuming that these statements I'm making, everybody's okay with, like 11 over 2, 11 over 5 is more than 2, a little bit more than 2.
Yeah, so if someone wants to ask a question in the chat, go ahead.
And if not, I'll keep going.
Yeah.
Okay. So same thing here. And again, all of these, obviously you can recognize the format now. These are all taken from that practice test. I look at these answers. I haven't even read the question. And I notice that I've got some numbers that are less than $100 and I've got some numbers that are more than $100. So now I go to the question and it says he's earning 80% of $175. So I'm thinking, well, is 80% more or less than 100%? Well, 80% is less than 100%, but it's not far from 100%, right? It's more than 50%. Well, 80% of 100 would be $80 already. He's earning $175. Could he possibly be earning $14 or $35 if 80% of 100 is 80? No, he can't. He's clearly earning more than 80% of $100. So I can eliminate A and B again. So now I'm picking between C and D. I'm not going to continue that one. You're free to do so. If you think of 80% as dividing 100 into 5 pieces and taking 4 of them, you could set up the proportion and say, okay, I can divide 175 into 5 pieces and take 4 of them. And maybe you choose to do it as a representation. Maybe you choose to do it numerically. Maybe you're allowed to use the calculator on this one, and you know that 80% of is the same as 0.80 times. Lots of different ways to do this question, and any of them are fine. All right, an important thing to do, and this isn't just for multiple choice questions, it's for any kind of a question, and particularly helpful in a math question, is to reframe the question to make it easier for you. So how could we reframe this question so that we don't have to do long division? Nobody likes long division. I don't like long division. I can do it, but I don't like to do it, and I will avoid it anytime I can. So I might look at this and go, well, I've got, it's saying 34 times something is going to give me 6,905. So I can sort of start to get close if I take 34 and I multiply it by 100. If I multiply 34 by 100, I get 3,400, and I'm still not up to 6,000. So again, I look at these choices and I'm going, well, it can't be less than 100 because they seem to have divided the answers into more than 100 and less than 100. And if it was less than 100, then it would be less than 3,400. So it can't be 100 that I'm multiplying by. So now, okay, let's assume, because the only two answers that are left are 203, it's 203. So now I've got to decide if it's a remainder of 3 or if it's 0.3. Now this one's tricky, and I'll tell you what I think, but maybe you would see it differently. When I look at the 0.3, I'm thinking that if that was what I was multiplying 34 by, so 203.3 times 34, then I'd get a decimal in my answer. It doesn't matter what decimal, I would get a decimal. But 6,905 doesn't have a decimal. So it can't be D. Well, it can't be A, it can't be B, it can't be D. So I'm pretty sure it's C. And if you wanted to, you could verify that it's C by multiplying 34 by 203. And everybody likes to multiply better than dividing. But even so, if you can convince yourself that that's true, just go with it. Just be confident in your reasoning. All right, again, we see that they have less than $1 amounts and more than $1 amounts. So I would ask myself, will 14 cookies be more or less than the cost of 12 cookies? Hopefully your answer is 14 cookies will cost more than 12 cookies. And 12 cookies cost $7.56. So it can't be A or B. Like, again, these are obvious things that you can do to rule out, to get yourself to 50-50 from 1 and 4. You know, you're much better off with having to decide between 2 answers than 4 answers.
So Judy, it's a better ratio.
It's a far better ratio, indeed. So you're just looking for, like, what's clearly not even reasonable. This is a question that we're supposed to teach students to ask themselves, but we rarely do. It's definitely in the elementary curriculum to ask students those questions. Well, this one's pretty similar, except now we've gone down in the number of avocados rather than up in the number of cookies. Could the price of one avocado be more than $3.70? If 5 of them are $3.70. Again, this is just shopping. You know this. Well, no, but the only one that's there that's clearly wrong is D. That's fine. So we've eliminated one. But it can't be B or C either. And why is that? Well, because they're both more than $1. And if you multiply 5 times more than $1, you get more than $5. But the cost of 5 is less than $5. So it can't be B, C, or D. It must be A. I haven't had to do division. I haven't even had to set up a proportion. All I've done is reason my way through. So I'm not keeping track here of how many questions we've done with no computation whatsoever, just by eliminating the clearly wrong answers. And I recognize that we sometimes only eliminated 2 of the clearly wrong answers. Is there a question? I see you.
Yeah, there are a few here. It's just, are there examples of questions without calculators? I can answer. I'm going to come back to another question. I'll just leave those with you, and then I'm going to answer this question. Maybe you can think about those, Judy, and then just, it's a comment. I didn't even notice the other options before. I just went straight into calculations. So, and it's just a shout out, a thank you for those tips. The other question I'm just going to deal with, and I'll just leave those with you, Judy,
Okay,
is
yeah.
do we have any examples of what pedagogy questions would look like? And I think I want to clarify a little bit here around the pedagogy, because it's really not specific about the pedagogy of mathematics. They're more questions about pedagogy that's in policy documents. And so it's really, it's more a sort of a test of the policy documents, which, you know, have some elements of practice in them, but they're not really specific. I mean, we've taken sort of exception, I guess, with the government about the fact that the pedagogy it really isn't about math pedagogy, or so I don't know if that's helpful, but
Yeah.
so they're more around the policy documents than they are about math pedagogy. And what Judy is really doing here is actually indicating some of the pedagogy.
Thank you. You noticed.
Mathematics.
Thank you. Yeah, it actually is indicating some of the pedagogy. And I think the reason probably that it was included is because, and I don't think I'm telling tales out of school here, but maybe don't go around quoting me on this. Math teachers have frequently taught as if the rules for good pedagogy don't apply to them. So differentiating instruction, having small groups working together on problem solving, giving student voice so that they can express how they see things rather than doing things in a prescribed method. All of these things are good pedagogy, but they're not, they have not been part of what you see when you walk into a math class too frequently. So I believe that probably what they're trying to do is to make it very clear that the rules for good pedagogy apply whether you're teaching math or not. And in some respects, I appreciate that emphasis. I do. For assessment, good, like, growing success, good assessment practice is not pre-test quiz partway through a chapter and then a test at the end of the chapter. That's not good pedagogy. Nor is it good pedagogy to lecture and then give a task for students to perform for marks at the end when they've actually not learned by doing tasks, or vice versa. Have them doing tasks in class and then give them a test at the end, pencil and paper. These are, like the assessment and the way students have been taught, the way they've had their instruction should match, they should align. And again, teachers trying to adopt something new for teaching mathematics may have had a disconnect there where they might have had students working in groups on a nice task, but then give them a pencil and paper test. That's not good pedagogy. So just to say that these documents apply to everyone. There is a new document that's not listed there, by the way, just for people who are going to be teaching math, and I highly recommend. They're on the digital curriculum platform, which is where the new curriculum is being housed for the Ministry of Education. And it's in the resources section. You can get to it for either from the elementary or the secondary path. And that is high impact strategies for mathematics instruction, high impact practices, I think actually it's called. It's really good, but it doesn't say anything that isn't in those other 3 documents that they suggest you become familiar with.
I'm just going to pop that link to the digital platform into the chat box for everyone in case everyone doesn't know it's there.
Thank you. And if you feel like taking a stroll, go down on the left side, go through resources. I know this website way too well. Go down the left side to the resources, click on that, and one of them will be the high impact strategies. It's really
just by default, the link that I put in here, it's sending you to the elementary, but there's a separate tab on that page when you land there that shows secondary. So
yeah, and absolutely doesn't matter.
Yeah.
And again, so this is another new policy document that applies to all math, whether it's elementary or secondary, and it doesn't matter what grade. Okay, another strategy that you can use if you look at this and you go, oh yeah, in grade 9 we learned these rules for exponents. I don't remember what they are. You shouldn't try to remember, you should understand them. If you can't understand them, recreate them. So I would say that you could just simplify it into something that you can do and understand. And so change, okay, you know you have to multiply 2 powers. So pick 2 small powers, 2 cubed times 2 squared, because this is likely going to be one of those things that you can't use a calculator for. They'll make the numbers so big that even if you could use the calculator, your calculator display would go wonky. So 2 cubed times 2 squared, you know that's 8 times 4. If you have to, use your fingers. 2 times 2 times 2 is 8. 2 times 2 is 4. And Joe Bowler, who's a math education guru, would tell you, use your fingers. You do better at math if you use your fingers. They've again done research in that. And so that's 32, and 32 is the same as what? Well, 2 times 2 times 2 times 2 times 2, so 2 to the 5. Okay, now I remember the rule. I have to keep the base the same, and I have to add the exponents together. So now you look at which answer keeps the bases the same and adds the exponents together, and you have your right answer. You do this when you can. You can't always simplify a question, but with things like rules like this, simplifying it is fantastic. So you've now created the rule all by yourself. All right, so I look at these answers, these choices, and I notice that we've got 2 denominators of 10, 1 denominator of 20, and 1 denominator of 13. Frankly, I look at the denominator of 13 and I go, ugh, because it's not a friendly number, but 10 and 20 are very friendly numbers. And so the discount is not 65%. That's what you have to pay. So the discount is the rest of it. It's the 35%. And that's a fantastic thing when you go into a store and it's 30% off. So you have to pay 70%, and which means you can, in your mind, you can multiply by the 7. And you have a ballpark of what this thing is actually going to cost you. So doing that little bit of subtraction, paying very careful attention to what the question is asking you and telling you that the first thing is what you're paying and the second thing is what you're saving. So what you're saving is the 35%, and 35, however you arrive at that, it's definitely not 6 out of 10. It's definitely not 3 out of 10. Maybe you notice that 35 over 100 is the same as 3.5 over 10. Maybe you recognize that that is the same as 7 over 20. And you didn't have to deal with the yuck over 13. So again, be very careful reading the question, because you know how to do this. You do this all the time.
Judy had an experience like that. Just that's really, 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 really good advice about any question on an assessment. So in grade 12 in the Quebec system, I was they had sort of standardized exit exams, or grade 11, sorry. And I know I made an error on that because my father was the English teacher, and I misread a question and answered, not in mathematics, in language, and I got to know that I hadn't answered the right question, because you don't get the test back. But he asked me about it afterwards, and he said, clarified for me. And I just did one of those, oh no. I still passed, but it was good learning from there on, and I read very, very carefully.
Yes, yes. I didn't know you were from Montreal. I'm from Montreal, so we'll have to reminisce with our provincial exams at the end of grade 11, or I don't know, you're younger than me, so yeah. So we never got to see them because they were sent off in the mail to be marked by a stranger. But we digress. Okay, so this is a nasty looking long division question. Again, I would avoid long division anytime I possibly could. And when you have multiple choice, there's a very good chance you can. So it's further complicated and made miserable by the fact that it's long division with decimals. So now you got to remember the rules for decimals, and then you got to remember the long division rules, and like, I don't care. So I would suggest that 17.86 divided by 0.19 is the same question as 1786 divided by 19, whole numbers. Like them a lot better. That's indeed what you're doing when you're moving the decimal over when you're doing long division. But the reason that you can do this, and the reason why you can treat this question as 1786 divided by 19, is because all numbers stay the same in their value when they're multiplied by 1. And it doesn't matter how you represent 1. You can represent 1 as 2 over 2, or 13 over 13, or 62 over 62. In this case, with decimals, you want to use 100 over 100. 100 over 100 is 1. When we multiply by 100 over 100, we get 1786 as the numerator, and 19 is the denominator. So now I've got a question that I can actually deal with the numbers. I have a sense of these numbers. So I'm going to ask myself now, 1786 divided by 19, that's asking me what number would I multiply 19 by in order to get 1786. Well, I have no idea, but you could start, actually, you know what? Maybe I'll let you guys reason this one out. What could you see in this question that would allow you to at least eliminate some of the answers, if not get to the actual single correct answer without doing long division?
We'll give some folks some time there, and you can just pop your thoughts into the chat there.
So I'm reframing the question as, what number do I multiply by 19 in order to get up to 1786? Perhaps you've by now noticed that we have two answers that are bigger than 100 and two answers that are smaller than 100.
So Judy, just to reiterate, you're just asking folks to reason this out, right?
Yeah, to see what they can do with purely with reasoning. By the way, as you're reasoning, you may notice that, again, those numbers are the same. So they're looking to see, do you know how to deal with decimal points? Well, I'm going to change the question so I don't have to deal with decimal points.
So we've got one that's come back here. It wouldn't be too big, so not 814 or 940. And someone else come back with, they're not sure. And then looking to actually do the long division.
Okay.
Yep.
Well,
so some support would be helpful here, I think.
Yeah, sure. So I'm noticing again that two of the answers are bigger than 100, two of the answers are smaller than 100. If I took 19 and multiplied it by 100, I would get 1,900. And that answer is bigger than what I'm trying to get to, which is 1,786. So I can reason that the answer I'm looking for can't be greater than 100, which allows me to eliminate A and B. Now, of the two answers that I have left, 94 and 81.4, we've talked about this in a previous question. What's the difference between those two numbers that pops out apart from the fact that they're different numbers? Well, one of them has a decimal and one of them doesn't have a decimal. Do I want a number that has a decimal to multiply 19?
So folks did see that it was the decimal there in the difference between C or D.
Great. So is the place I'm trying to get to 1786, is it wanting a decimal or it's not wanting a decimal? It's not wanting a decimal. So again, I would say that, you know, once you start to look for these things, you can answer these questions without the long division. Yeah, and you don't even have to, you know, if you were allowed to use the online calculator, you wouldn't even need that, because you've reasoned your way to the correct answer. And by the way, if you have time left over and you want to check it, you could do 94 times 19 and see if it works. If you really wanted to do you could do 94 times 0.19 and see if you get 17.86. And maybe you do that after you leave the session, just to convince yourself that all of this is not, it's not smoke and mirrors. It's actually solid reasoning. Again, I'd love to know how many questions we've answered without doing any computations, just by reasoning our way through. Again, this is a math proficiency test. It's not a math test. It's how well do you understand how numbers work. It's not how well can you repeat the long division algorithm, you know, or how accurately can you repeat it. Okay. Again, with respect to reframing the question, I have 3/4 plus 6 minus 1/4. I'm adding two numbers, subtracting one number. And I know that quarters are actually, you know, a physical thing. We have quarters in our money, in our Canadian money. So suppose I were to exchange $6 for quarters. How many quarters would I get? I'm thinking you probably know, especially if you, although I haven't lived in an apartment for a while. We used to always have to get quarters for the laundry machines. All right, so now you've got, like, I believe it's 24 quarters.
Come back in the chat, so they're just checking your math too.
Thank you. I think it's 24. And you already had 3, because there's 3 quarters in your hand already. So you've got 3 quarters in your hand. You added 24 quarters to your hand. You now have 27 quarters. And I don't know, you use one of those quarters, you drop one of those quarters. How many quarters do you have? And I think it's super interesting, this question, because pretty much every math teacher would not accept any of these answers. 4/8 can be reduced to 1/2. 10/8 is an improper fraction. It's 1 2/8, which is 1 1/4. 8/4 is 2. 26/4. Like, they wouldn't accept this answer, and yet those are the choices that they're giving you. This demonstrates beyond anything I could ask for, that they're not asking you to do math class math. They're asking you like to do practical math. It just maybe doesn't look so much like practical math when you see it as what is the value of this string of operations with numbers. But that is actually what it is. All right, is everybody okay with that? All right. Okay, so order of operations. Again, I might think of shopping where, you know, I've got 2 of something. I have to multiply those together before I add up the things I bought 1 of. So I'm buying, you know, 2 pairs of jeans, a sweater, and I don't know, a wallet. So I'm going to multiply the cost of the pairs of jeans first, and then I'm going to add the cost of the sweater and the cost of the wallet. That's order of operations. It's actually sensible. It's not, again, it's not anything mysterious. So here you're basically adding or subtracting 3 numbers: the cost of the sweater, the very cheap jeans, maybe they're flip-flops, and or maybe it's subtracting. So, you know, like maybe it's you're returning 2 pairs of flip-flops, and then you're buying something else that's $9. So those 3 numbers together, 17, subtracting 6, and adding 9. I put this question in simply because I wanted to highlight that the order of operations isn't a mathy thing. It's actually a life thing. We do actually usually multiply things together before we add them up. There's one exception to that fact, and that is tax. We add things up before we add the tax.
I've got a question here, Judy. Is BEDMAS still applicable?
Yes, it is. I hate my own personal bias here. And again, I am a little different. I hate BEDMAS. And this is because years and years and years of teaching, no students can recite it. They don't know what it means. And so an acronym that people can recite without understanding is of no help. In particular, the bracket's the first thing in BEDMAS, which in the UK is PEDMAS, which is parentheses. Students in calculus could not explain what that means, and that's shocking. So I would argue just understand how numbers work and how operations on numbers work, and don't memorize something that you don't fully understand. DM, division before multiplication, no, that's not true. They come in whatever order, and addition, subtraction come in whatever order. So yeah, but yes, this is order of operations. And if BEDMAS helps you because you actually do understand it, that's what we're talking about here.
So the supplemental here was just, it said, because I've seen other acronyms, so I didn't know if this had been replaced. That's
yeah, no.
You've addressed that point.
Yeah, and in fact, you won't see BEDMAS anywhere in the curriculum. You'll see order of operations.
So just a question in here, just for the benefit of everyone, and maybe Judy, you can take this one too. For this question, would you do multiplication, then move left to right?
Once you've done the multiplication, you can do whatever you like, provided you recognize that you're subtracting the 6. So you do 17 minus 6 is 11, plus 9 is 20. You do 17 plus 9 is 26, subtract 6, that's 20. If you want to, you can start with -6 and add 9, get to +3, and add 17 more, you're at 20. It doesn't matter how you do it. All right. The only thing that you can do wrong is not doing the multiplication first, or ignoring the fact that that number has to be subtracted. You have so much freedom. And in fact, we do this all the time. We group things how we see them. Like some people like to group numbers into 5s. Some people like to group numbers into 10s. We're free to do that as long as we pay attention to, you know, if they're just being added, that's fine. All right, so place value. This one, if you, again, reason it out, will never cause you any trouble. How many of these things do we have? Well, and again, I can't see my screen, so I'm going to have to move people out of the way. I can't move people out of the way. There we go. Yeah, so we've got 3 of the millions, we've got none of the 100,000s, we've got 2 of the 10,000s, 7 of the thousands, 9 of the hundreds, 6 of the tens, and 8 of the ones. So look at what you see going down there, and you've got your answer. Where does the 0 go? That's what they're asking you here. A doesn't have a 0, and then the 0 just moves position. So where does the 0 go? We could do the same thing now. Maybe you want to try it, but I do have a lot more to cover, so I'm going to go through. We've got 19 of the thousands, no hundreds, 7 of the tens, and none of the ones. So that's 19,070, and I've got my answer. And this practice just happened to have 3 questions that were basically about place value, so that's the reason I wanted to talk about them. So we've got 7 of the millions, 0 of the 100,000s, so we can eliminate A. 6 of the 10,000s, okay, that's B, C, and D. 1 of the thousands, and 4 of the hundreds, none of the tens, 1 of the ones. So if you just, again, look where the 0 belongs, the 0 is in the 100,000s and the 0 is in the tens. So you should have no 100,000s and no tens. And I know algebra is where some people go off the rails, usually between grade 8 and grade 9, where algebra becomes more part of what we do. Again, you don't have to solve this. All you have to do is verify that 12 works. So you can substitute 12 in, and again, you do have to remember the order of operations. Putting 12 in A, that's what brackets is, by the way. The first thing you have to do is evaluate what's inside the brackets. And that gives me a negative number, so it can't be A. And 12 times 8 is huge, and it's only going to get bigger when I add 4, so it can't be B. 12 times 2/3 is going to be positive, and then I'm adding something more to it, but on the other side of the equal sign is a negative, so it can't be C. I've eliminated A, B, and C, and I actually haven't solved the equation. So
Judy,
watch, yes.
We've got some questions still around circling back on the issue of BEDMAS, which.
Oh, sure.
Do you want to address those now, or?
Sure. No, absolutely. Yeah.
Yeah. So the question.
The time to learn is now. This is right.
There were 7 questions. There were several questions here. But should we ever use BEDMAS? Then how do we know if we should? And then when I used BEDMAS for the last question, the answer was incorrect. So
the
can't
equation.
remember which one that was.
That equation.
Megan, can you tell us which one? When you said the last question, the place value one.
There's 3 place value questions.
This one? I'm just looking for Megan had asked the question there.
Or this one?
17 minus 2 times 3 plus 9.
That one.
Yeah.
Okay.
Operations. Okay.
Yeah, order of operations question. Okay. No, what I'm sorry if I wasn't clear. I'm not suggesting that you're not using BEDMAS. What I'm suggesting is that you don't need to use the acronym BEDMAS. It's only helpful to you if you understand what brackets, exponents, division, multiplication, addition, subtraction means, right? So what I've experienced is that because we're very sloppy, and again, Ian and I were talking about this, we're very sloppy as math teachers using language. And we might have something that, in grade 9, which is when you'll see it, 2 times bracket x plus 3. And we'll say, okay, we're bringing the 2 into the bracket, or we're opening up the bracket. And so they think that that is bracket because that's what they've heard for years, when in fact that's multiplication. And that's going to mess them up. The same thing if we have x plus 2 in brackets with squared. And we might say we're squaring the bracket. And so they think that's bracket. But it's exponents, it's not brackets. So this is part of the problem, is that if you've got, like, it's great to have brackets, exponents, division, multiplication, addition, subtraction, provided you know what each of those components of that acronym mean. Without meaning, it's just something you've memorized. It would be like memorizing a poem in a language that you don't speak. You can recite it, but it's not useful.
So in fact, it can lead to essentially to misunderstanding or interfere with understanding.
Yes, I believe it can. It can actually send students down the wrong path. So as with most things, if you understand it and then you get a memory tool, that's okay. But to give a memory tool in lieu of understanding, really bad idea. It's just like giving somebody a procedure without understanding. There's a very good chance they're going to forget it, or go, is it this one or that one? Do I need a common denominator when I'm multiplying fractions, or only when I'm dividing fractions, or only when I'm adding fractions? I don't remember, because you learned a rule that didn't make sense and wasn't explained.
Yeah,
So
sorry, that's great. So in this question, so Megan's just coming back to ask this. Can you
yes.
just go through on the right-hand side where it says you're adding and subtracting 3 numbers and just talk through what you've actually written there on the right-hand side?
Sure, yeah.
Question is just noticing now, why does it say add after 17 when there is an addition sign?
Oh, I'm sorry. There's 3 numbers, 17.
Sorry, it's actually a subtraction sign. So what I'm confused about is it says, like, the numerical equation says 17 minus 2 times 3 plus 9.
Yeah.
But on the right-hand side, you have 17 add.
Yes. So that's an instruction for what to do to the 17. If you notice at the bottom, the 9 says add.
Yeah.
So the 17 gets added, the 9 gets added, and the 2 times 3 gets subtracted.
Okay.
So it's what do you do with those 3 numbers? So extract from that sentence.
Here, yeah.
Yes, go ahead.
Is the correct answer here A or B?
I want to ask what do you think, but I don't want to put you on the spot.
No,
so
that's okay, because earlier when you were speaking, I think you were implying that it was B, but
yes.
That's why I was saying when I was doing the BEDMAS, yes. I was getting A. So that's why I'm kind of circling back to it, because the way that I was doing it was 17 minus 6 plus 9. And then yes. I would break that down to 17 minus 15, which is 6 plus 9. And then 17 minus 15 is 2. So I'm getting A.
So you were doing 17 minus 6 plus 9, and you were getting 17
minus 15, which is 6 plus 9, right?
Right.
And
but
then 17 minus
it's
15.
not 6 plus 9. The 6 isn't being added.
Okay. So that's why
the 6 is being subtracted. Yeah. So if you're going to group them that way, it's 9 minus 6. The 6 has to be subtracted from whatever number. It can be subtracted from the 17 or the 9, or it can be subtracted from the sum of 17 plus 9, but it has to be subtracted.
Okay.
Is it really okay?
It's just I've grown up using BEDMAS and it's usually worked for me so far, except for when I did this equation, it's not. And I'm still not really sure how it's not, but that's okay.
Yeah. Well,
it's just one question.
Again, no, but it is important. I mean, one question out of 40 is, you know, like you don't want to miss that one.
Mm-hmm.
You know, and I understand that I wonder if there were brackets put around the 2 times 3, if that would make you more comfortable.
That's what I was just going to say. I did the exact same thing as Megan, and because I grew up using that as well. And I was looking at it again, and 100%, if we'd had brackets there, it would change how you thought, right? So I think it's just, we're not used to doing it without those brackets, right? So it's just a switch in our thinking too. Like, this is why it's really tricky for a lot of us that are maybe older going into this. Like, I know Megan and I are both a little older, and in terms of like, we're not fresh out of teachers college in like as a 20-year-old. So the way we did math is so different. So the fact that we have to do this test on top of the new math curriculum, right? It's just a lot to kind of take in and manage all at one time.
No, for sure. I totally understand that. And that's one of the reasons why I actually put these resources in the way I did, like the box on the side. Like there are 3 numbers there that require adding or subtracting. So the multiplication has to be done before you do the adding or subtracting of those 3 numbers. But the one thing you can't do is lose sight of the fact that the result of the multiplication, which is 6, is being subtracted. So whether the brackets are there or not, it still has to be subtracted.
I understand that. It's just, I think because using that BEDMAS, I'm so used to doing addition first. So I had that 17 and then I have the subtraction sign after that, but then I'm doing 6 plus 9 first, because under that acronym, addition is coming before subtraction. So I'm doing that addition of 6 plus 9 first. So I'm just not really sure at what time that changed.
Okay, it didn't. It didn't. The 6 was never an addition. The 6 was always a subtraction. So, and that's one of the problems with the BEDMAS, is that it isn't true that addition comes before subtraction. Addition and subtraction can happen in any order. It doesn't matter. Just the same as the multiplication and division can happen in any order. They put the D before the M and the A before the S to make an acronym that you can pronounce. If they had done BEMDSA, you wouldn't be able to say it. So it was purely to make something that people could say. There is no rule in mathematics that says that multiplication comes after division, nor is there a rule that says that subtraction comes after addition.
Yeah, so I think your piece there around, you know, having added, if you added in the parentheses, you know, yourself in this question, it would, don't want to use simplify there, but it would.
Yeah,
I understand now. Thank you.
Yeah, okay.
Okay, so I'm just watching time. We've hit 5.
As am I. Yeah.
So maybe one more thing.
Let's see, where did we get to? Yes, we're going to I took a question that this is actually fairly long. So like if you, I don't know, Ian, can we do this question if it's okay with you?
Oh, yeah, go ahead.
We can
Absolutely.
stay? Okay.
Yeah, absolutely.
All right. So this was a question that I happened to notice in one of the other OTF sessions, and it's taken from a grade 9 EQAO test. And it says that each sail of a sailboat has a height to length ratio, height to length of base ratio of 3:2. And if the length is 9, which of the following properties? Again, it's fallen in behind your, I've got something covering my screen. There's a lot of distractor here that you don't need. Basically, all you need to know is that a height is 9. You need to find the length, and the height to length is 3:2. So if we take away all that other information, I'm sorry, something's gone wrong, so maybe we should stop. Am I out of order? Right. This is the original question, and it had a picture of a sailboat with a sail. And people looked at it without reading the question and saw a right triangle. And when people see a right triangle, they automatically think Pythagorean theorem. And in fact, this is not a Pythagorean theorem question. This is a ratio proportion question. And I think that it's easier to see that it's a ratio and proportion question when you take the picture away. So the picture actually leads you down the wrong path. So the Pythagorean theorem is about right triangles, and it's about any kind of a right triangle. It doesn't matter what the right triangle looks like or how that right triangle is oriented. And it's very useful. But the problem, I think, with understanding the Pythagorean theorem is that it describes a relationship between areas. The square on A, B, and C, A squared B plus B squared equals C squared, is talking about an area. Anything that's squared is an area. So it's talking about the relationship between the area of the square that you can draw on side A and the area of the square that you can draw on side B and the area square that you can draw on side C. And this is how students learn at first, or they're supposed to learn at first, according to the curriculum. They don't learn A squared plus B squared equals C squared yet. They learn this relationship. So they learn the Pythagorean theorem talking about areas. However, the Pythagorean theorem is not used to compute areas. It's used to compute length, which is just centimeters, let's say. It's not squares anymore. Maybe we need the length to calculate an area. So the Pythagorean theorem is especially confusing because it isn't actually talking about areas, even though it's based on areas. And I'm just going to very quickly flip through all the questions that I found on the practice test that have a right triangle in there somewhere. And my intention was to identify when we needed to use the Pythagorean theorem. We don't, not in this one, because all we need is a length. And this was describing how we would do that question. This is another question. Oh, sorry, this is the same question. So no Pythagorean theorem required. This also, you can see a right triangle in that picture. We don't need the Pythagorean theorem for this question because we're just talking about the area and we're given all the information we need to come up with the area of the triangle. We don't need to know the unknown length. The unknown length would be this slant length here, and we don't need it. No Pythagorean theorem required. This one has a right triangle. Do we need to know this slant length? Well, actually, we're given the slant length, so we don't need the Pythagorean theorem. So all of the questions that look like they might use the Pythagorean theorem actually don't require it at all. So it's really, really important to understand what the purpose of the Pythagorean theorem is, and it's to give you an unknown length if you know the other two. So in this triangle, we could calculate this length, and it would indeed be 10 using the Pythagorean theorem. In this one, we could calculate this slant length, the hypotenuse, but we don't need it. So please don't assume when you see a right triangle, don't start using the Pythagorean theorem, because it's going to take a lot of time and it's not going to give you any information that you actually are going to find useful for solving the question that you're given. So that does actually take me to my almost goodbye. What I tried to do was demonstrate how many questions you can actually reason through without the how-to. We didn't actually need to know how to do much of any of the math that we learned in school, but we understood sort of like what's reasonable and what can be eliminated. But if you want to learn more about the how-to, we math teachers hate Khan Academy, and yet it's very helpful. If you go into the math page, and I've got the link there, if you go into the math page, you can see all of the different by grade, but this is US grade, but anyway, by grade, you can see the different things, the different concepts in mathematics. If we click on it and we go into a grade, and I don't know, let's see, equivalent fractions, say, which by the way, we didn't really need in any of the questions that we saw. We can do a practice. And when we're doing a practice, if we can't get a question right, this is adorable, we can watch a video. And the videos are actually quite nice because they actually explain everything that's happening. So there's multiple choice questions for you to practice. There's a video that helps explain how to do that particular question. If you don't want to watch a video, you can get a hint. So again, please try to reason as much as you can. It's far faster and far more reliable than doing a bunch of computations, especially computations by hand or using a calculator that you're not familiar with. But if you want to do the how-to, Khan Academy, it's pretty good.